Good afternoon, class. Thank you. You can sit down. All right, in this lesson, we are going to correct the last 3 questions on the previous exercise based on angles of elevation and depression. That is question 13, 14, and 15. Then we are going to look at bearings. All right, question 13. It says the figure below shows a tower TR and an observer at O from O, which is 100 meters from the base R of tower TR. The angle of elevation of the top of the tower is found to be 35 degrees. Okay, first thing you have to calculate the height of the tower to 3 significant figures. Any answers? Daniel?
70.0 meters.
70.0 meters. B. The observer walks forward towards the tower until the angle of elevation of the tower of the top T is 45 degrees. How far does he walk forward? Kila.
30 meters.
30 meters? Okay, and C, find the distance of the observer from the base of the tower when the angle of elevation of the top is 65 degrees. Give your answer to 3 significant figures. Miriam.
$32.6 meters.
32.6 meters. Okay, is there anyone who doesn't know how the answers were calculated? You all agree with the answers then? Okay, next one. A man standing on top of a cliff 80 meters high is in line with 2 boys whose angles of depression are 17 and 21 degrees. Calculate the distance between the 2 boys. Any answers? Lester.
$53.6.
53.26. 53.26 meters. Is there anyone who needs help with question 14? Okay. It says a man stands at the top of the cliff, and it says the cliff is 80 meters high. It says the man standing on top of a cliff 80 meters high is in line with 2 boys whose angles of depression are 17 and 21 degrees. Okay, first, sorry, we have to get the angle of depression from the top. Okay, this one is 21 degrees. And then this angle will be 11 degrees, which is the same as, not 11, 17. I don't know where I got 11 from. Okay, you are told that, you are asked to find the distance between the 2 boys, which is this. Do you know, have you seen what is called boys? Yes. Huh? They are the things that float on the sea by, I think the ships carry them. Huh? Okay. Whatever. Okay, first, You have to use 21 degrees. You have to find the distance from the base of the cliff to the first buoy. Let's call it Y. And then you also have to find the distance from the cliff to this one. We'll call it D. Okay, X will be equal to Y minus D. Okay, the problem I see in this case is that you are told that the man is standing, but you are not told the height of the man, which means you have to assume that he's very short and his eyes are on top of, just on top of the cliff. So if you put the man standing up on the cliff, you will not be able to answer the question because there's information missing. So the first thing you need to do to find Y, you will have to say 10, 17 degrees is equal to Y on 80, and Y is equal to 80 multiplied by 10, 17 degrees. Then you have to find D, 10, 21 degrees is equal to D over 80, and D is equal to 80, 10, 21, and then you subtract X is equal to Y minus D. Okay, so you should get this answer here if you subtract correctly. Is it clear now? Okay, next question. You are given a figure. It represents two plotting stations A and B, 4,000 meters apart. T is a stationary target in the same vertical plane as A and B. It is recorded that when the distance of the target from station A is 10,000 meters, the angle of elevation is 29 degrees, and the figure is shown. First, you have to find the vertical height of target Tx. Any answers for that? Margaret?
Tx equals 4,848.1.
Okay, this should be X, right? Okay. So Tx again, please. Sorry, Margaret.
4,848.1 meters.
4,848.1. All agree? Ax. George.
$8,746 meters.
Come again, please.
8,746 meters.
Is that to the nearest whole number?
Yeah.
Okay, see, Andrew.
$4,746 meters.
4,000. Or is it 8,002?
4,746.
746 meters. And D, Peter, the angle of elevation of the target T from B.
45.6 degrees.
And E,
6,784 meters to the nearest whole number.
6,800 and
6,784.
the nearest whole number. Okay, and that's question number 15. Any questions? on those three? You all got them correct? Okay, I hope so. Next thing, we're going to look at bearings, which maybe you did a little bit of it in grade 10. I don't know whether in social science or in maths. Okay, bearings is used to measure directions from one point to another. It is always measured from north going clockwise. So you start from north and you go clockwise to the right. Okay, these are the 3 points that you need to remember. And it is measured in degrees as a 3-digit number. Okay, I've got the compass, the directions on the compass here. I've got north, east is always towards the right, west to the left, and south down. Okay, I've divided that in 2 again, and I've got the line that indicates northeast, that's between north and east, and southeast, southwest, and northwest. From north to northwest, it is 45 degrees. But if we write that as a bearing, it will be written as 045 degrees. Okay, from north to southeast, okay, the bearing from north to southeast is 135 degrees. You always start from north and you go clockwise and back. Okay, next one, I've got the bearing, the angle southwest from south is actually 45 degrees. But the bearing is always measured from north, so to start from north and go southwest, it will be 180 plus 45 degrees. The answer is, the bearing is 225 degrees. Clear? And I've got another one. From north and you go to northwest. Instead of going from north and going anti-clockwise, the rule is that you start from north and you always go clockwise. So from north to west is 45 degrees. The bearing from north to northwest will actually be from north all the way to the line that indicates northwest direction. It will be either 270 plus 45, which is 315, or 360 take away 45, which will give 315 degrees. If the direction northwest, it was written as north 45 degrees, northeast, north 45 degrees, east. So you know that you start from north and you go 45 degrees and you will get to that direction. You will get to that point. If there was an angle here, let's say this one is 45 degrees, which is southeast. Southeast was measured as, or was written as south 45 degrees east. So you know you start from south and you go east. Nowadays, it's not done that way. In maths, especially in social science, you probably still write bearings in this way. In maths, we stick to a 3-digit number. So this one is 045 degrees. Southeast will be 135 degrees. So once I say that someone is on a bearing of 135 degrees from a point, then you know that that's south 45 degrees east. Okay. I've got some examples. It says, for the following, find the bearing of B from A and also the bearing of A from B. Okay, A is this point. This line indicates that's the direction of B from A. That's where B is in relation to A. You are given an angle here which is 20 degrees. So north is this direction. This angle from north to the line that indicates that's where B is from A. The bearing of B from A is 0 to 0 degrees, because that's from north going clockwise, and you stop at the line that indicates that's the direction of B. So that's 20 degrees, but it's 0 to 0. Now, if we wanted to find the bearing of A from B, what I usually do to make it easy for me, I draw north, east, west, and south lines here. Because I know that I have to start from north. That line indicates north. Okay, if this is 20 degrees, this angle is also 20 degrees because it's alternate to this one. Okay, now, what is the bearing of A from B? Anyone? Gabriel?
200 degrees.
Huh?
200.
200 degrees. Okay, the bearing of A from B is 180 plus 20. So 200 degrees. Okay, next one. Okay, that's point B. Can anyone tell me the bearing of B from A? Given that this angle here is 30 degrees. The bearing of B from A. Which direction is B from A? Southeast, but what's the bearing? Anyone? Daniel?
$150 degrees.
Okay. Oh, sorry. Are you sure it's 150 degrees? Okay, it's 180, take away 30 degrees. Okay, next. What is the bearing of A from B? Then, the bearing of A from B is
330 degrees.
330
30.
degrees. Who else agrees with them? 1, 2, 3, 4, 5. 5 people only. Okay, this angle is alternate to this one, so it's also 30 degrees. Take away 30 degrees from 360 and you get 330 degrees. So she's correct. Okay, next one. What is the bearing of B from A? Quick. Siegfried?
$291 degrees.
291 degrees is correct. It's 270 plus 21. You start from north And you stop at the line that indicates the direction of B from A. So it's 270 plus 21. What about the bearing of A from B? The bearing of A from B, anyone? Livingston.
One hundred and 11.
111. 90 plus 21 is 111 degrees. Okay, I've got two more examples. This time there are two word problems. We have to draw the diagram and see if we can answer the questions that follow. An aeroplane flies 200 kilometers on a bearing of 147 degrees, and then 50 kilometers on a bearing of 237 degrees. How far is it from its starting point, and on what bearing must it fly to return to base? Okay, I am going to do this one, and then you will do the next one. Okay, an aeroplane flies 200 kilometers on a bearing of 147. 147 is 57 degrees more than 90. So 90 plus 57. So the plane flies in this direction. It's 147 degrees. Okay, and it flies 200 kilometers, a distance of 200 kilometers. From here, it then flies on a bearing of 237 degrees. 237 is between 180 and 270. So, and 50 kilometers is 4 times less than 200 kilometers. Okay, so that would be 50 kilometers. The bearing from north to here will be 237 degrees. The question is, how far is the plane from its starting point? Which means we are going to find this distance, because this is where the plane is now. This is where it began. And we are also going to we are also going to find, okay, we are going to find the direction. Okay, if this is where the plane is, we have to find the direction that the plane will have to fly to go back to where it came from. Okay, have a look at the triangle that I've got on the board. Okay, if the direction here is 237 degrees. Solomon, what is this angle? No, just this angle. I want this angle here, just this one. 33 degrees. Okay, this angle is 33 degrees. If from here to here is 147 degrees, what is this one? What is this angle here? Agnes. Use the mic. Pass the mic.
$57 degrees.
57 degrees. And you get 57 from here. They are alternate angles because it's 90 plus 57 will give you 147. And 237 take away 180 will give you 33 degrees. So this angle is actually a right angle. That means, how are we going to find the distance the plane is from its starting point? Use Pythagoras theorem. Okay, the distance is equal to the square root of 200 squared plus 50 squared. Point 201. Okay, 206.2 kilometers. Next thing, you have to tell me how we are going to calculate the bearing. The plane has to travel back to where it came from, to its base. Any ideas? Okay, the direction we are trying to find is this one. From north, we have to measure from north all the way to this line, because that's the line that tells you that that's the direction from base. Now, my question is, how are we going to find that angle? If you know the answer, please pick up the mic and tell us. We don't have much time. Do we need to calculate some angles? Which one? This one? Okay, I'll make it theta. What trig ratio am I going to use? Peter, please. Cosine or tangent?
Tangent.
Okay, tangent of angle theta is equal to 200 over 50. All right, find the angle for me. Theta is equal to Natasha.
$76.
Is that to the nearest whole number? Or? Okay, 76 degrees. Now, we don't need all of this angle. We have to get rid of this bit here to find the bearing. So, Jake, how are we going to do that? If theta is 76 degrees, what is this angle here? Just this one. It is 57 degrees. It's the same as this one. It's 57 plus 33 plus 57 will give us 90. So we have to remove 57 from 76 degrees. That will give us this angle. And then we will have to subtract that again from 360 degrees. So 76 take away 57 is 19 degrees. So the bearing that the plane has to fly to get back to base is 360. Take away 19. 341 degrees. Now you are going to do number 2. I'm going to give you only 5 minutes. Okay, example 2. Any answers for the distance, how far apart the ships are? Yes, pond relay.
100 kilometers.
100 kilometers. What about the bearing of A from B? Anyone done that yet? Okay, you are told that two ships leave port at the same time. Ship A travels on a bearing of 60 degrees at 20 kilometers per hour. Ship B travels at 330, on a bearing of 330 degrees, and it travels 15 kilometers per hour. What you do to find the distance, you multiply the speed by the time, and you get 80 kilometers here. Here you will get 60 kilometers. And you have to find how far apart the ships are. If this is 60, 330 from 360 will give 30 degrees. So this is a right angle triangle. So you can use Pythagoras theorem. So this is 100. Okay, to find the bearing from from B to A. Is that the, okay. All you need to do is, this angle is the same as this, which is 30 degrees. You have to find this one, okay, which I think is 50 degrees. Please check. 56 degrees. Use tangent. Tangent of this angle is equal to 80 over 60. Just check this, please. Is it 56? 53. Okay. If it is 53 degrees, the bearing is from, because this is the north line that I've drawn, the bearing is from here to here, because that's where A is from B. So all you will do is take away 30 and 53 degrees from 180, and you will get the bearing, which is what? 97, but you will have to write it as 097 degrees. That's the bearing of A from B. Okay, for homework, you are going to do question 1, 2, 3, 4, and 5, 6, and 7 only. Okay, the rest of the questions we'll do later on. Okay, the keyword for today is bearings.